Some of you guys like the Edpuzzle videos, and some of you really don't like these videos. If you prefer the worksheet model where the readings are kind of just embedded in and you're answering the questions based off of that, what you could do is turn off the volume and just read the slides and answer the question. You can fast forward and rewind as much as you'd like, okay? If you prefer to listen and read, then you can just follow along with me, and that would be great too. But you pick whatever works for you. So we're starting our last unit on astronomy, and I think this one is a pretty fun one. We only have 10 lessons left, which is pretty exciting. And the school year is almost over, so great even within all this craziness, right? So today our lesson is, how does energy from the sun heat the earth? This person is saying, ouch. So we can all pretty much imagine what happened here. They probably touched this hot kettle, and the heat from the kettle transferred from this to the hand. So when heat is being transferred because of touch, because of contact, we call that conduction. Heat is transferred through contact, conduction, contact. We see another example of conduction here. This hand is holding onto the handle of the pot, which heats up as the pot heats up, right? And then the heat from the handle is transferred from here into the hand, right? So again, heat transferred through contact, we just call that conduction. There's a couple of different forms of heat transfer. Conduction is just one of them. There's two more forms of heat transfer happening here, and we're going to talk about those too. So we already kind of went over convection when we were talking about the layers of the Earth. There are convection currents inside of the Earth, inside the layer called the asthenosphere, and it's what causes the plates to move. But how do convection currents work? Just as a review, remember we had that blue food coloring and the red food coloring. This represents hot water, this represents cold water. When a substance is cold, just like you guys, the molecules move closer together. And when you take a mass and you confine it to a smaller volume of space, you make that thing more dense. So the cold substance is always more dense. It's going to sink to the bottom. When a substance heats up, those molecules, just like you guys, when you're hot, you move away from each other. So when a substance heats up and the molecules move away, it becomes less dense because you're taking a mass and you're spreading it out. So this is less dense and it rises. Then at the surface, this water cools down, becomes more dense, sinks, heats up, becomes less dense, rises, cools down, becomes more dense, sinks, and then this process just continues in a cycle. So convection currents happen in a cycle. Whenever you see that loop, it's an example of convection. Heat is transferred due to differences in temperature, and wherever you have differences in temperature, there's a difference in density. The last form of heat transfer we're going to talk about is called radiation, and this is happening in the form of waves. So your hands aren't warming up because you touched the fire. Your hands are warming up because the heat from the fire is radiating off and warming up your hands. If you touched the fire, that would have been conduction. But because this is happening through these waves of heat, this is called radiation. Heat flowing in the form of waves through empty space. So I'm going to show you a couple of examples. I want you to tell me which one is conduction, which one represents convection, and which one represents radiation. Just remember, conduction, contact. Sorry, let's go back here. Conduction, contact, convection, cycles. Remember those loops. And radiation happens in the form of waves. So which one is conduction, which one is convection, and which one is radiation here? Now, why does cheese melt on a hamburger? If you get this wrong, it's okay. I'm just kind of testing you guys out. But why does the cheese on the hamburger melt? If you said conduction, you are correct. The cheese melts because it's in contact with the warm patty. So again, if it's happening through contact, through touch, that's going to be conduction. Why does the firefighter have to crawl along the floor? What do you think? Is this conduction, convection, or radiation? If you said convection, you would be correct. What I see happening here is you have your fire. This heat from the fire warms up the air, And what ends up happening is this warm air becomes less dense, it rises towards the ceiling. The cold air is more dense, it sinks towards the floor, and that's why the firefighter has to crawl along the floor. He doesn't want to stand up and breathe in this rising smoke. The smoke would choke him. It's better for the firefighter to breathe in that clean, cold air. So again, I see that loop that tells me it's convection. And then how does energy from the sun heat the earth? If you said radiation, you would be correct. I see heat being transferred in the form of radiative waves. Anytime it's in the form of waves through empty space, again, it's radiation. Now, heat can be transferred from the sun through many different wavelengths of radiation or many different, so let's go over this actually. We're going to go to page 14 of your reference table. There's this diagram. It's called the electromagnetic spectrum. So the sun emits energy in the form of waves that reaches the earth. Now, each of these wavelengths has a different name. So you got your gamma rays, your X rays, ultraviolet rays, infrared rays, microwaves, and radio waves. Now these, it says increasing wavelengths. So these are longer wave radiation. This is the longest wave radiation here. And this is decreasing wavelength. These are short wavelengths of energy. So these are very short wavelengths of energy over here. But again, each wavelength of energy from the sun has a different name. As you go to this end of your table, the wavelengths are increasing. They're becoming longer wave radiation. As you go towards this end of the table, the wavelengths are decreasing. These are short wave. This is short wave radiation. So short wave to long wave radiation, right? And over here you have your visible light. Same thing here. These are shorter wavelengths of light, and these are longer wavelengths of light. This is the color that you see. Most of the energy from the sun actually comes in the form of visible light. Now, again, when I say long waves, what does that mean? Well, long waves look like this. We call these low energy waves or low frequency waves. This is shortwave radiation. This is high energy waves, high frequency waves. I can see a lot more of these crests, right? So this is high frequency. When we think about this in terms of sound, the long wave, low energy waves produce low sounds. The shortwave, high frequency waves produce higher pitched sounds, like sharper sounds. Now again, just remember decreasing wavelengths. If wavelength is decreasing, it's becoming shorter. It starts to look like this. If the wavelength is increasing, like we see here, these are longer wave radiation. So long wave radiation looks like this. I really should have flipped this. We're going to come back here. Electromagnetic radiation from the sun comes in many different wavelengths, and all the different wavelengths have different names. These are the different names here. Just remember, these are the longer waves, these are the shorter waves. If you have your reference table open in front of you, I would write that down. Long wave, short wave. Okay? So answer this question: what type of electromagnetic radiation has the longest wavelength on this table? Which one of these has the longest wavelength? If you said radio waves, you would be correct. Remember, increasing wavelength. It's getting longer over here. These are the long wave ones. Short wave on this side. Right now, so there are a couple of different factors that's going to affect how much energy from the sun is going to be absorbed by Earth's surface. Some of this you're already familiar with, just like on a hot day, what color do you want to wear? Do you want to wear black or do you want to wear white? On a hot day, you're probably going to choose to wear white because this reflects more light. It's going to keep you cooler if the energy is being reflected off of you. Black colors will absorb more of the sun's heat. It's going to make you feel warmer. So darker colors absorb more heat, more energy. Lighter colors reflect more of the sun's energy, right? The same thing goes for textures. One texture is going to reflect more of the sun's energy, and one texture is going to absorb more of that energy. And you could probably guess which one will do which. If you think, well, when we look at a smooth surface, what do you think? It's going to definitely reflect more of the sun's energy. A rougher surface is definitely going to absorb more um, energy. And why is that? Let's look over here. Look at these arrows. These represent the electromagnetic waves coming in and being reflected off of a surface. On a smooth surface, it comes in once and kind of just bounces off. Just remember, whenever a wavelength, whenever electromagnetic waves hit a surface, so at this point, whenever they hit the surface, yes, some of it bounces off, but some of it is absorbed. Now you'll see that this only comes in like once, bounces off, once, bounces off, once, bounces off. This is nice and clean, right? But over here, it's a mess. There's so many different surfaces here that it comes in, bounces off, hits another surface, bounces off, might hit another surface again, then bounce off. So every time it hits the surface here, it bounces off and then re-hits another surface, some of that energy is being absorbed. Rougher surfaces, because more of these electromagnetic waves are, with rougher surfaces, because the electromagnetic waves hit the surface many times, more of this energy is going to be absorbed. So again, darker colors absorb more electromagnetic waves, more energy from the sun, and rougher surfaces also absorb more of the sun's electromagnetic radiation. So go ahead, based on what we just talked about, answer this question. If you picked 2, you would be correct. A dark green forest, darker colors are going to absorb, it said absorb here, so it's going to absorb more of the sun's electromagnetic radiation. And a green forest, a forest is a rough surface. A rough surface is definitely going to absorb, again, more of the energy from the sun. And then go ahead and answer this question. Which one represents conduction, which one represents convection, and which one represents radiation? All right, you guys.